This is section 2.4, and we're going to be talking about imaginary numbers today. You've done imaginary numbers before. That's the imaginary number I, and it helps you deal with when you're taking the square root of a negative. So today you're going to be able to write complex numbers, and that's what they're called. Anything with an I is called a complex number. It's called imaginary. And we're going to add, subtract, and multiply them. They work very much the same as x's do. There's just a little twist to them at the end. So where i's come from is if you tried to solve this, you would end up with x squared equals -1. You would try to square root both sides, and what you'd be trying to square root is a negative. And if you type that into your calculator, it will not work. So what we came up with is we said, okay, then the square root of I is just going to be called, the square root of -1 is just going to be called I. We're going to substitute that in so that we can keep doing the math with it. It's almost like, it is literally substitution. We took this guy out and we put that new value in. So we know that I is just the square root of -1. And we'll talk later about what all these other i's mean. So just to do a little bit of math with I, anytime you have a negative inside of a square root, you deal with the negative first. So you'll just pull the negative out. What you're essentially doing is separating the two. And then you're saying, well, the square root of -1 is I, and then the square root of 4 is 2. Or we would write 2I. We kind of write the I in the same place as we would put an X. Next one, the 12 would come out. The negative would come out as an I, and you'd be left with the square root of 12. And you can leave it like that, that's okay. If you know how to break down 12 into 4 and 3, then you'd have the square root of 4 and the square root of 3, and square root of 4 is 2I. These guys, again, you got to do the negatives first. You have to take care of that. So you have an I square root of 10 and another I square root of 10. So what happens is your I and your I come together, and they make I squared. And we'll talk about that in a little bit. And then square root of 10 times square root of 10 is literally like having square root of 10 squared. So the square and the square root cancel each other. I squared is a neat little number. I squared is actually -1. So we're going to do -1 times 10, which is -10. And we're going to talk about more of that in a little bit here. Write down these blanks. Last one, I've got square root of 2 times square root of 12. Just so you know, you multiply the insides together. Kind of like we did there, it could be square root of 100, which is 10. So I have the square root of 24, and then I could break that down into 4 and 6, so square root of 4, square root of 6, and get 2 square roots of 6. Just a little refresher on radicals there. So the first thing you know is that I is the square root of -1. We just talked about that. I squared would mean I'd have 2 of those, so that would be a -1. I cubed would be a negative of this guy. So it's -I, and then I to the 4th is +1. And then they rotate after that. I to the 5th is actually I to the 6th is -1, I to the 7th is I to the 8th is 1, and then it repeats. I to the 9th, I to the 10th, I to the 11th, I to the 12th. So every 4 values repeats itself as to what the I actually equals. When you are doing problems with complex numbers, you never, ever, ever want to see square root of -1. You actually never want to see I squared as well. Put both of those, either or. You only want to see plus and minus I or plus and minus 1. These are the two we deal with all of the time. You'll rarely see a third or a fourth power. We usually just deal with the I's and the I squareds. So let's talk about what it looks like when you're doing some math with it, some operations. So the first one, it has a minus sign right here, so I need to distribute that. So I've got 5 minus I minus 2 and then plus 4I. And you can just add like terms together just like you normally would. Kind of works like an X in that manner. There's nothing real special about it. The only thing that becomes special is when you're doing a problem like this and you start to multiply, 3 times 4 is 12I, minus 5I, and then minus 4I squared. So you can put together these two guys and make 7. And then this I squared turns into a -1. So you have 4 times -1. So you click that, and these two guys end up together. So 15 plus 4 is 19 plus 7I, that's your final. You do not want to see, that's awkward.
Sabrina Asif, please come to the admin office, please. Sabrina Asif, to the admin office.
Right in my video. So I squared, you never want to see, so you always want to be replacing that if you see it with a -1. Okay. Next one, squared just means write it twice. So 1 plus 7I and 1 plus 7I. Foil that out, you're going to get 1 plus 7i plus 7i plus 49i squared. When you get a little bit faster at these, you can just take that guy out and switch the sign, so that's negative. So 1 minus 49 is negative 48 and 14i. One last one, we'll FOIL this, so you get 16, you get plus 20i minus 20i and then 25i squared. Again, you can kind of get rid of that and just switch the sign. So 16 plus 25, we can put those two together and make like terms. And then when the middles come together, here you have a plus 20 and you have a minus 20 because in your parentheses you had 1 plus and 1 minus. So these are called conjugates. They'll cancel each other out and you're just left with 41 as your answer. The very last one we have is called a conjugate. So you want to simplify this. And the only reason you want to simplify is that the I is actually a square root. And you can't have square roots in the denominator. So what you do is called rationalizing. You've done this quite a few years in a row. I think you actually skip it in geometry, but you've done it before. What you do is you take the bottom, which is the thing causing your problems, and you multiply by the conjugate, which is the same thing but with a different sign. So if this had been minus, these guys would be pluses. This is a plus, these guys are minuses. And it has to be the same thing on top and bottom, okay? So these are conjugates. One's plus, one's minus, same exact thing. These guys are conjugates, plus and minus. Now we're going to FOIL both the top and the bottom. It looks a little messy at first, but you'll see why we're doing this in a second. So we've got 8, we've got minus 6i, we've got minus 4i, and plus 3i squared. On the bottom, because they are conjugates, they won't have a middle. The middle is going to go away. So we have 16, and then we have minus 9i squared. So I can get rid of this guy, change the sign, and get rid of this guy, change the sign, and now I can just add like terms. So I've got 8 minus 3, which is 5, minus 10i, all over 16 plus 9 is 25. You could go one step further and take a 5 out of everybody. And so your final answer could be this. I would take either one of those, though, on a test. This is called rationalizing. You're just trying to get rid of the square root that's in the bottom, and it's in the form of an I.